In this challenge, you'll be creating a text-based game using a hash map. This game will be loosely based on the original Colossal Cave Adventure, which was one of the first adventure games and came out way back in 1975. Feel free to Google that if you want to find out more information about this game. This slide shows a conceptual map of the game I want you to build. The game starts with the user standing in a road in the centre of the map. North would take the user to the forest and south would take the user to the valley. East would be the well house and west would be the hill. For simplicity, you'll just need support north, west, south and east compass directions. So each location will only have up to at most 4 directions to choose from. In other words, you won't support diagonal moves such as moving northeast, although you're welcome to code your game that way if you want an additional challenge. You'll want to use 2 hash maps in this challenge, one for the board locations and one for the next place's data. This slide shows one way to structure your data, but feel free to come up with your own configuration if you'd prefer to. Use a hash map for the game board locations, keyed on a short descriptor, road or stream for example, or some other key of your choice. Your location class should have a location description and could also have a field, a hash map, to store next places to go from there. The next places map should be keyed by the compass direction and its value should be the key to the next location. As an example, the stream location will have a next places map which has 2 entries. The first entry will have a key of W or west and the value will be valley or whatever key you would use to get the valley data from the board locations map. Use the console to describe to the player what their current location is, starting at the road, and show the player what options they have to go from here. Feel free to edit the descriptions and make them as detailed as you want. Prompt the player to enter the direction they want to go next. You can accept the whole word east or just the letter E. You can let the user know what lies ahead by giving them a hint about the next place or not. For example, you could just tell them they could go either east or west and offer no hints. Continue to play until the user quits, perhaps using Q for quit. I've included some starting data as a CSV file in the resources section of this video. If you want to use that, you can copy and paste it for now and set it up in a text block, or you can set up your own set of data from scratch. I'm showing a sample of what the console display might look like on this slide. This is a suggestion only to help you understand how the game might work. Feel free to be creative with your own version. A bonus part of the challenge is to allow customizations to the board locations as well as the next place directions. For example, your player should be able to add custom board locations to include more places or change the descriptions or destinations available. Okay, so it's time for you to attempt this challenge. When you're ready, come back and I'll walk you through my solution. How'd you do? Did you have some fun with that? I've created a new project called Adventure Map with the main class and main method, which I'll get back to in a bit. The first thing I want to do is create a class called Adventure Game. I'll set up a text block that contains all my board location data. I'll make that private static final and a string with a name Game Locations all in caps, because this is a constant. I'll create that constant first with the triple quotes, leaving an empty line between. I'll paste the text. I want to make sure the start of my strings line up with the closing triple quotes so there aren't any unnecessary leading tabs or indents. The next thing I want is an enum that will have my compass points, so E, N, S and W. I'm going to add a method in this enum, so I'll end my list of constants with a semicolon and a new line. I want to add a private static final array of strings, and I'll call that directions, which will just contain east, north, south, west, in the same order as the corresponding constants. In an upcoming section of the course, I'm going to look at how to use constructors to do this, as well as other more advanced initialization topics in general. Until then, this code will work just as well. I don't want to override toString here because I want the compass points to be printed as single characters as well. I'll next add a getString method that takes no parameters and returns a string. I'll return the value I get from the directions array when I index it by the ordinal value of the current enum. The ordinal method on enum gives me its placement in the constants list. If I have S, ordinal will be 2, and using that to get the element from directions will give me the string south. The next type I want is a location record, which I'll make as a nested type. This will have a description and a map field called next places. This map will be keyed by the compass direction and will hold the key to the next location, so a string. Okay, so that's my location, and now I can focus on the game itself. I want 2 fields on my adventure game. First, I want to keep track of my last location, so I want a string called last place. And then I need my hash map for the board locations. My variable type is map, and my type arguments are string for the key and location for the value. I'll name it adventure map. I want to generate 2 constructors. The first will be a noargs constructor. Leaving that as is for a minute, I'll generate the second one. And I'll pick last place from the fields. This last constructor isn't really going to accept the last place because I want to change that to custom locations. I want players to have the ability to customize the map so they can pass a well-formatted string to this constructor. I'll remove the current statement in this constructor. Before I can complete these constructors, I need some code that can pass my board location data or any custom location data that's in the same format. For that, I'm going to create a private method, void, load locations, and that takes a string I'll call data. My data is set up as a text block, but this could also be data coming in from a file or whatever. This data will have line breaks after each data entry, so I want to split this data by a line break. I want a for loop that will iterate over each line, so on the right of the colon in this loop statement, I'm going to split the string by 2 backslashes and an R. This is a way to split up my text block by each line. This escape sequence, 2 backslashes and an R, was introduced in Java 8 and matches any Unicode line break on any operating system. If you used a \n, that's good too, but this is just a bit more robust. After I get each line, I want to split it into 3 parts, the first and second comma delimited parts, and then anything else after that as a single string. To do this, I'm going to use the overloaded version of the split method, passing the comma as the delimiter, and 3, which is the total number of parts I want this record to be split into. The last part, the third part, will contain all the data after the second comma, and it will include commas if any, which this will have since it has all the next place's data. After this, I'll use a list backed by an array, chaining the replace all method to that, calling the strings trim method reference. This is a quick way to remove leading and trailing spaces from my array of strings. To create each location record, I first need to create the next places map. That map will be keyed by one of the compass enum constants, and the value will be a string. I'll assign that the result of a method load directions and pass that the last string in my string parts array, which has all the direction data in it. I haven't created this method yet, so that's not going to compile. I'll create this method shortly. I'll create a new instance of the location record, passing it the second delimited string, which had the description and the map next places. And I'll put that new location into my adventure map. I am purposely using put and not put if absent. This will make the customization piece easier. Finally, at the end of this method, I'll print out the adventure map, the key and value for now, so I can test it. Now I need to code the load directions method. That will be private and return a map and has compass as a key and string as a value. It'll take one argument, a string, and I'm going to call that next places. I want to set up a local variable that has the same type as the return type of this method. I'll call that directions and set it to a new hash map. I'm going to split the method argument by commas again. This was everything after the second comma on each line from my input data, so it's got a comma delimited list of compass directions and next places to go. I can pass that to the asList method on arrays, and I'll assign it to a local variable next steps. I'll again call the replace all method on that, along with strings trim method, as I did in the other method, to remove leading and trailing spaces. Now that I've cleaned up my data a bit, I want to loop through each delimited string. Each string from my data has a compass direction, followed by a colon, followed by a string, which is the short descriptor of the next place. The first thing I'll do in this loop is again split the current string, and this time by the colon. I'll trim the first part and pass it to the value of method on compass, which will return a matching compass constant. If you were building this in a real environment, you'd want to make sure the data provided was really clean, meaning the compass direction is actually in your enum, but I'll keep this simple to save a bit of time. The destination will be after the colon, so that's the second element in the splits array, and I'll trim that. Finally, I'll put this data into the map, the compass as the key, and the destination as the value. These directions are all the possible ways a player can pick from to move to another location. I'm going to pause here, so if you didn't code this yourself already and you want to pick up from this point and work through it, give that a try. In the next video, I'll pick up from this point, complete my constructor, test loading my map, and then add code to play this game. I'll see you in the next video.